So for those of you who've just come in, I'll paste the link again. And maybe you can start working on it. Awesome. So people have already started posting on. I think I can give you a few more minutes. Gosh, it's already at 7. So maybe 1 or 2 more minutes and people can continue to post. And this is why I request you to please be on time so that we don't waste so much time in just coordinating what the links are. Maybe it was a terrible idea to engage you. Okay, people have their hands raised. Yes. So let me also go and. Does anybody have a question? I see a lot of hands raised.
Ma'am, I'm wondering, once we're done taking the quiz, where do we post the results?
Your voice is breaking for me.
Yeah, so ma'am, I'm wondering, once we're done taking the quiz, where do we post the results?
I've shared a Padlet link. I'll share it one more time.
Okay.
So, and I've also kind of pasted an example there as well. So you can just write the number and stay on this link because I have a follow-up questions for that as well. So this is what the link should.
Ma'am, can you just write the number like what is overall calculation?
Yeah, you can just write the number as well. That's absolutely fine.
Okay, ma'am.
Okay. And then, so all of you need to have a separate post so that I can then later see who's posted it and who hasn't. And then in the comments, if I can request you to kindly put what's your consumption by category. So once you get the results, you'll say view results. So if you go to view results, you will see a detailed infographics on what your consumption is. And if you could just go there and tell us what it is category-wise. Okay. And then once you do that, and while everyone else is doing it as well, and please continue to give the quiz and paste the results, we will come back to it. And at some point, I want you to think about what is the number that you got, which categories are the ones that you contribute the most to. So I can already see people saying how much the emissions are in tons, and by land use, by energy, what is the distribution of your share or your footprint in that particular category. And just post that so that we know what the explanation to these 3 Earths, 4 Earths, 5 Earths, or 2 Earths is. And we'll get back to it towards the end of the discussion. And I think if you continue to do this for me, I'll be super grateful. And then we can come back to. For those of you who just joined or are joining, as I can see people are still coming in, please try to come in on time. This doesn't help you, me, or anybody. Maybe Nadia or Joshin can send the links again in the chat box, and I can start with the presentation. So essentially, you have to calculate your footprint. You have to stay on that page. Once you go to the results, it will give you a distribution by category, that is by land, etc. And then you'll post the results on the Padlet link that will also be shared with you in the chat. And we'll come back to this discussion very, very soon. Okay, and then let's now get to the discussion for those of you who have already finished the pilot, and hopefully those of you who will continue to listen. So last time we stopped at natural capital. If any one of you could tell me what did they understand from the activity that we did quickly, because we do not have a lot of time. What did they understand from the activity of just looking at that one tree and looking at the resources that that tree has, or the services that that tree provides? And if you could raise your hand or just use the chat function, that would be great, because then we might want to build. Okay, who has raised their hand? Suba, is it you who's raised your hand to answer the question? Because some hands were already raised.
Go ahead.
Yes, yes.
Right. So the exercise that we did yesterday actually made us all realize how pertinent trees are and how we might take them for granted, because there's a lot that goes on behind the scenes. So, for example, we talked about food production and then climate control, air purification, all those things that we have learned in basic sciences, for example, in 5th or 6th grade. But then again, trees have advanced functions as well. And one of the most important things is that if one tree can do all of this, then all of these trees together in a cluster can do so much more. So if you're taking one tree for granted, then you're technically taking the entire group of trees for granted as well, because one by one, if you chop them down, ultimately by thinking that it's not something which is very pertinent to the environment, then it's going to lead to a domino effect, right? And it's just going to overall pollute the environment as well, and have like a very huge impact because of the overall impact that taking trees for granted will have on the society.
Absolutely. And thank you for bringing that back. So I called it a natural capital. And then I made you kind of look at the services. So in itself, it's a resource. There are a lot of resources that we take away from it, but there are also those silent services that we do not notice. And this goes for every species, every natural capital that is present on Earth. We kind of don't look at the ecosystem services or the natural services that it provides us with. So this is an explanation, and it's in your book chapter as well when we finish this today, and you can go through it, that the natural capital, which we'll continue to talk about, is the resource itself, but also all the services. And for example, if it's air, then the air controls our weather, and then those weathers control our overall climate. There's an ozone layer, which of course you hear a lot about, and how it's naturally placed there for us to have a filtered sun or solar radiation so that we continue to thrive on this planet. And similarly, like all the other resources which we'll look at, but maybe something to focus on would be the renewable energy and the non-renewable energy. So some of it is there, and it's going to continue to be there. So for example, sun or the solar light, wind, and water flows. Whereas others are non-renewables. For example, fossil fuel, on the one hand, it's like absolutely not clean. That's also something that we'll discuss, but it's also non-renewable, which means that we have a reserve of it. And if we finish it, we finish it. It's not going to be renewed because it takes billions of years for it to be formed. And then also some of the minerals. We'll talk about some elements that are essential for life on this planet. So we'll talk about their cycles. But we also have to think about these non-renewable minerals that are not going to be renewed. So even for them, we have a certain resource that we need to be cognizant of. And yeah, like something for us to be grateful for, like for how we continue to get clean air and continue to get clean water, and for all of this biodiversity to give us this population control. Otherwise, we'd probably just kill one another if the populations were not to be controlled. And I want you to, and this is not from your book, by the way, this is something that I wanted for you to see in terms of the interaction that we have, or in terms of how related everything is, and why we need to think about it. And please, if you have a pertinent point, do raise your hand, and and suggested to the class. It's difficult for me to read every chat because then I forget what I had to say. So basically in this slide, I kind of wanted you to have a look at the air, land, and water interaction. And in this particular slide, I've given more emphasis to, for example, the water resources. So I've said, okay, within water, there's surface water, there's ocean, and then there's groundwater, how that interacts with the land, because whenever, for example, it rains, the rain is going to percolate down and add to the groundwater aquifer that we have. And so that resource will build. But similarly, the water that's on the surface, in the oceans, it will evaporate and contribute to the water cycle. And that's why these spheres are continuously interacting. Now, this is something that has happened naturally, right? There's a physical environment, there's a biological environment, and currently we're probably just talking about the physical environment of how they interact, of how things move between these different spheres. Very simple, we're not thinking about anything else. But if we now think about, let's say, human intervention into it, we now are considering a society that practices agriculture. And I picked agriculture because we are a country that relies heavily on agriculture. Now that air, water, land interaction, which is super simple, which is that one is contributing to the other and there's a balance. And I think that the word balance is really important because the system naturally is balanced, right? That they interact between other and they try to keep a balance. You know, naturally we have some differences as well, but most of it is like very balanced in terms of what's coming in and what's going out and how is matter flowing and how's energy flowing between these spheres. And we'll look at that in a while again. But now we add a human society into it and just look at how the interaction has changed. Because now we are adding waste into these resources that were otherwise not present there, right? So for example, we are adding certain chemicals into water. We are adding certain particulate matter or smoke, etc. In the air. We are adding extra crop residues in the land. I don't know whose mic is on, but it's creating noise. So if you could keep your mic on mute, or if you want to talk, just raise your hand and I can let you take the stage. Okay, so basically what I wanted you to think about is that naturally there are these spheres and they interact between each other. Then we come in and we change a lot of things about these spheres. And this is going to relate to the ecological footprint calculation that you just made, right? Because now we have come into a system and now we are producing extra waste. And that waste has to be absorbed by the system, right? That waste has to be taken care of by the system. Otherwise, the system will not be balanced. The system will be off balance, right? So if there's so much human waste or animal waste around in this environment, that it will not be easy for us to live in that environment. So we have to create a system where this interaction is not disturbed. And that's why I think it's important for us to think about our footprints and the spaces we take on this planet, or the spaces we actually need on this planet, and how much space can the planet afford to give us in a certain country, in a certain community. So we looked at the natural capital. Now we'll look at the renewable resources and how we have. So when I gave you that interaction glimpse or blurb, it was sort of for you to think of how when we come in, the entire system and the entire interactions change. So we looked at the natural capital, right? We looked at how the water is being purified naturally, the air is being purified naturally. There's a balance in the system in terms of mass and energy flows, and how that ensures a perfect, suitable condition for life to thrive on this planet. But how are we, what are some of the ways, if you could quickly write in the chat box, in which we have degraded these natural capital, particularly the renewable resources? None of you is awake enough to just instantly write in the chat box, but yeah, pollution. We've polluted the air, we've polluted the water resources. So, and we've changed a lot about these cycles, the presence of these elements, deforestation. Wonderful, I can see a lot of comments that are also now in the box. By creating, by damaging that natural capital that exists, we have degraded that balance. We have changed a lot about it, and that's why it's important for us to come back and see what, how can we bring it back. Like, I love that concept of living in harmony with nature and coexisting with everything else that's around, for us to be not destroying it. Yes, absolutely, all of those things. Thank you for flooding the chat box. Okay, so up until now, we looked at the natural system, how it's there, how it's interacting, how the natural system has been built such that there is a balance, that whatever waste is created or however mass is moved into certain spheres, the spheres are able to take care of it. But if you look at, how we have intervened and how we have changed it, we've created a lot of changes in that natural capital, and that has resulted for a lot of issues that we now face and all the other species now face on the planet. There are a lot of ways to calculate the impact, and this particular model is very, very simple, which is why a lot of times we share it in our intro basic level classes. So the ways in which these impact can be calculated get very, very complicated. And we'll see how complicated the system is, right? So for example, for an agriculture society, you saw how the land, water, air interaction changed just because of us coming there and doing certain practices. So if we were to calculate the impact of the environmental impact that we put on a certain piece of land on the planet, the simplest model, which is called IPAT, is what helps us. And I'm going to make you think through some of this equation. It's very basic, but it gives you a nice glimpse of how to understand the impact that we have on the planet. So it says that it depends on the population. It depends on the consumption per person of that population. So let's say we were talking about the same agriculture community. So it would first depend on how many people there are. So let's say how the set of farmers that are there. Then it would depend on the consumption per person. So let's just focus on water. So let's say what the water consumption of every farmer in that community is. So the more the consumption, the more the impact on the planet, right? Or on the environment. And then the third is impact of technology, or the impact per unit consumption of the technology that will take. And this can be both positive and negative. And I'll ask you to think about it in the slide to follow, because I think I've put something there for you. But is there any difficulty in understanding this equation, or does anyone want to add anything? And thank you for putting in. Who has a point? Yes, go ahead.
No, the point with the conclusion. I just don't know what's the concept of per unit of consumption. Impact in the part.
Fatma, can you put your question in the chat box, because I hear you very, very light.
Yeah. Am I audible?
Yes, absolutely.
Ma'am, I don't know what is the per unit consumption. Is a question about this समझ आ गया.
The per unit consumption in terms of technology. So we will look at the technology, and that's why I'll give you a follow-up example. So for example, how do I, okay, so let's think about agriculture, right? Let's say I'm a farmer who is very, very smallholder in the north. Let's say in Hunza, I'm like a small farmer, and all I have is a pair of ox, right? Who do the tilling for me. See? And then there's a neighboring farmer who's relatively a bigger farmer and a richer farmer, and he has a tractor. And now one would think that technology has a positive role to play in the environment. But in this particular case, that technology is using additional fossil fuel. That technology is plowing at a rate, and we'll look at how plowing is bad for the environment. Let's say they till, so they upside down the soil, and that's not good for the environment, right? Because it releases all the trapped gases that are in the soil. And so let's just think of that impact per unit consumption of fossil fuel, because we're talking about the negative impact at the moment. So if you compare the impacts of me as a smallholder farmer who does not use a tractor that is run by diesel, versus someone who's utilizing that, if you look at the per unit consumption, because my consumption is zero, the impact would be low. and somebody else's consumption, my neighbor's consumption is high, whether that's electricity, whether that's diesel, whether that's, for example, a number of gadgets that are coming in, because if you go back, and we'll also talk about that at some point, of the energy that's spent on creating that machine, right? Of the energy that's spent on transporting that machine to my home or to my village. All of that then comes into account, and it depends on what you define the consumption. Do you just keep it to the fossil fuel use, or do you keep it to the fossil fuel use in the life cycle of that tractor? So I hope that that answers a little bit of it, and maybe you will have to think it through in the slide that I've just flashed, and I want you to think about it. So generally, like, I think it depends. So for example, if all the units were same, you could establish a unit. Generally, it's sort of more for understanding the discussion and the impact. And I'll come back to why this simple model is important, because it makes you think about the different factors that are responsible. Because oftentimes, for example, we talk a lot about water scarcity in Pakistan. Water scarcity in Pakistan is because Pakistan's being overpopulated, right? Because our population is really high. It's not that the amount of water has decreased. The water levels or the amount of water technically is the same. The reason why we are water scarce, or our cities are water scarce, is because the population is increasing. The population that particular resource could support is I don't know, increased by a scale where they have to over extract whatever sources of water were available. And that's why we are water scarce. The water level technically hasn't changed. Okay, so in this particular slide, I want you to think about the impact of two technologies. And just think simplistically, like, you do not have to think too deep down into the concept, but coming back to that idea of positive and negative impact. And I think I gave you a gist of it in the discussion about the farming communities. But let's say that we live in a community, and the technology that we use, last time we carried this conversation with a focus on population, but this time I wanted to think about technology. And when you go home, maybe I can ask you to give examples of how increase in one or decrease in one could change the impact on the environment. So let's say there's a solar tube well in a community, and then there is a filtration plant in the community. What do you think would, and let's say both the communities have the same population and the same consumption of resources in general. So we're not talking about any consumption in particular, consumption of resources by that community. So let's say if these two technologies are installed, which one do you think will have a higher impact, and what kind of impact will it have, and why do you think is that the case? Let me quickly go to the chat box. Yeah, so if we talk about impact in a certain place, and we will come back to it, we are talking about the population of that area only. So let's say if I'm talking about a farming community in Hunza, I am particularly referring to that population, their consumption, and an impact of a certain technology that they are using, because we've now scaled it down. We could take it really, really big, but I think for those bigger scales, these simple models are not enough. Then you have to take a lot of other things into account as well. Some hands are raised. Who can I take? Sarah, do you want to go first?
Okay, ma'am. So I think a solar tube well has the positive impact, क्योंकि अगर हम कोई और तरीके से पानी निकाल रहे होते ग्राउंड वाटर से, तो फ्यूल वाज नीडेड, और ये डायरेक्टली फ्रॉम सनलाइट है, तो कोई नेगेटिव इम्पैक्ट आई डोंट थिंक कि कोई है इसका। एंड वैसे भी बहुत ज़्यादा पॉपुलेशन तो वहाँ है ही, आपने कहा कि दोनों में सेम पॉपुलेशन, तो they need to get water out because they need it. So yeah, I think best option ever. Solar tube use.
So let me say that the particular resource that we are talking about right now is water. Okay, so forget everything else. We're currently talking about a community that uses water, And there are two technologies available. One is solar tube well and the other is filtration plant. And let's also put another setup now, another basic information, which is that this country has enough surface water available for itself. Who wants to go next? Maybe I can take Xenia or Afaq, one of you to speak, because you haven't spoken in the class before. Afaq, Xenia, and can any one of you say what you've written in the chat?
Yes, ma'am. Am I audible?
Yes, you are.
Yes, I've written that the filtration plant would have a more adverse effect on the environment because it would require, fossil fuel, but you said we are talking about in terms of water, right? But so personally, I think still the filtration plant would have an adverse effect because it would draw water at a more rapid rate. So, it would strain the resource that is already present.
Okay, awesome. Now let me add another condition into the baseline information. And that condition is that, okay, I said there is enough surface water available. Now I'm saying that the groundwater level is really, really low for that community. So same population, same consumption in terms of resources for both the populations. But for them, the water level is really, really low in the ground. And then the filtration plant and solar tube wells are two technologies that are available. Which one of the two do you think will have lower impact? And who can I take? Roja, do you want to talk?
So in the case that you just described, the solar tube well would be basically depleting the groundwater level. So that can be really detrimental for all the plants and other natural resources on the ground. Instead of it, if we favor the filtration plant, what can be used is sewage water or water that's already in circulation. Any water that is being used or being wasted by the households can be, instead of extracting more resources, that water can be reused. An example of this can be the fact that the swimming pool at Laos, it was filled once and that water is still being filtered out and reused instead of gallons and gallons of water being discarded and then refilled. So in such a scenario, filtration plant would be the more environmentally viable option instead of a solar tube, in my opinion.
Absolutely. And thank you so much to everyone who's taken part in the chat. I can see it's more or less similar to people who have spoken. The reason why I wanted to give you different conditions is, first of all, for you to know it's not a simple, this is better than that answer. And it's not, what we've been taught in the textbooks. For example, we've been taught in the textbook that solar energy is cleaner and it's better. But what if the groundwater levels are really, really low? And most of the solar tube wells, for example, that are being operated in Pakistan, they're not automated. So what happens is, as soon as the sun goes up, they would start extracting groundwater regardless of the need of the community. And then it's only when the sun comes down that the solar tube well will stop. So unless that system's automated, unless it is demand driven, and we know how much water we need and we extract that, I think that even the technology that comes with cleaner input can still have a lot of impact on the environment. And that is what I wanted you to start thinking about, that there's no simple answer to this question, right? And then in terms of filtration plant, what if that energy is also coming from, let's say, hydroelectric, which is renewable. And in this case, as we said, if the groundwater is really, really low and we have fresh water available on the surface, we can kind of retreat it, refilter it, harvest more rainwater, and make sure that instead of extracting our groundwater and depleting our groundwater aquifers, we focus more on this side. So the reason why I wanted to put this, and even when I am talking, as I change conditions and as I change statements, I will keep drifting between the two. But most importantly, in this case, I think I just wanted to start thinking out of the box, which is the fact that it's not like one situation fits all. It depends on where we are, what we are doing, which particular resource is more scarce and more valuable for a certain population, and then that of course depends on how we live. Another aspect to look at it, and that's definitely covered in your book, so I'll not spend too much time on that, is, just if the population is high, it's not important that the impact would be higher for that. So for example, if you look at the ecological footprint, and we might go to that, the ecological footprint for a developing country could be really, really low than a developed country with a much lower population. So the developing country has a much higher population, and you would say, okay, if the population increases, so you have an increase here, and then you automatically have the impact increase as well. That is also not the case, because ideally we are consuming very little resources. In the developing countries, we do not have a lot of resources. So if our consumption per person is low, let's say of a certain, even for fossil fuels, if our consumption per person is still low, because let's compare like a village in Hunza or a village in Pakistan with a village in the UK, they will still be spending or using more fossil fuels compared to us. So their impact would still be higher, even if our village is more populated than their village. So with this simple model, what I wanted you to know or understand is that it's very, very complicated. And it's, there's no right answer to this. There can be many right answers to this depending on which space you are and depending on what resources are more important to you. So yeah, like I said, debate, discuss, quantify, understand, and then understand the issue, and then understand the solution or the technology that could be there. So let's quickly come back to the ecological footprint. I can see the chat is also being added. Okay, there's talk about inefficiency of the technology, which is also interesting that you're already talking about it. But let's come back to ecological footprint. So you, as some of you filled those, and let's maybe go back to what you pasted. Perhaps then we can have an understanding of. All right. Awesome. I do not want to judge you, but it would be difficult for me to not judge you, specifically if you have 6.7 Earths. So basically, what the data tells you is, and I said this is an open space, and I'm not going to judge you for anything, but what the data tells you is that if everyone on the planet lived like you, that is how many planets we would need. So it's just an internal reflection for you, and I do not want you to feel guilty. I just want you to be conscious of your consumption pattern. And I'm not shaming you because of how you live. I'm just telling you that how you live, and if everyone else started living like you, that's the amount of Earths that we would need. So for example, for some people, the number of Earths is 2.7. And you particularly probably are someone who does not use as much resources, tries to share, tries to carpool, and still your impact is, or your footprint is so much higher. And if we keep scrolling down, yeah, so maybe I can look at the average of this class and tell you what your average is. But then there's also another important information, and let's maybe go to one of the lower number of Earths. So let's say there is an Earth that, an impact ecological footprint of someone says that if everyone on the planet lived like you, they would need 2.2 Earths. So one Earth is not enough. We probably going to need to go back and ask the solar system to create a few more Earths for us. But there's also another information on the top, which is your personal overshoot day. And does anyone know what overshoot day is? Because I'd be very happy if you do. Zan has raised his hand.
So, ma'am, by overshoot day, they meant that if the planet is like if someone with exact carbon footprint, just like you, are living on the planet, then the Earth's resources will be like what you can say will be consumed, or they will end on this day, like 16 June.
Okay, awesome. So I don't know, maybe you can go back. I think very recently, I think in July, if I'm not wrong, we already crossed the Earth's of overshoot, right? So basically what it means is however much resource we were supposed to be consuming in 2021, we have already consumed it by 16th June. And I'll go back to some other results and compare it with those as well. Okay, so for anyone who's living on the planet such that they would need 2.2 Earths for everyone, for the 7 billion people to live, you have already consumed the resources that you were supposed to be consuming in the whole year by 16th June. But how does that number change? And of course, like it's simple to make that infer that from the data that we've seen already, that for anyone else, if the number of Earths increase, their overshoot day would come really, really early, right? And for anyone who's using very less resources, and a lot of times it's not our fault, and I'll talk about why it's not our fault. For someone who's living a little more resource intensive life, the overshoot day is 20th March. So between 16th June and 20th March, there's so much more resources than, let's say, this particular individual has consumed. And like I said, I do not want you to feel guilty. I just want you to be conscious, and I want you to start living consciously. My carbon footprint or my ecological footprint increased drastically when I no longer had the option of traveling public, right? For example, we used to have this shuttle service from Askari 11 to Lams. The day they stopped it, I had no choice. So after a few months, I had to buy a car, and my footprint suddenly increased. I did not have a choice. If I had a choice, I would continue to travel by the shuttle service. The house that I'm living in, I would love to live in a 1-bedroom apartment. Again, all the blames are going on Lams, so I think my report card is still clean. So the house that I live in, I would love to live in a 1-bedroom apartment, but we have a 3-room apartment that the Askari apartments have. So don't write those things, don't get me restituted. Okay, so basically, because I don't have that option of living in a smaller space, because automatically then the electricity consumption and everything else will decrease, the footprint for me has increased. I would love to use more renewable resources, even if I have to pay higher bills, right? So for example, if the city administration says that if you want 30% of your electricity to be powered by solar, you will be charged XYZ amount, I would definitely say yes to that. I'm happy to pay more money for clean energy to come to my home, but we don't have those sort of options, right? So here, like, I don't have a choice. I want to live more ethically, and I want to just restrict my consumption to 1 Earth, such that it comes down to 1 Earth, but I don't have a choice. So oftentimes I think we have to think about those as well. And let's quickly, because I know I'm spending a lot of time here, so maybe we can quickly look at the consumption the consumption per category. And again, like I wanted you to think about what is the area that consumes the most energy for you. So for someone, it could be goods. For someone else, it could be food, specifically if your food is not local, if you're importing it, if it's coming from longer distances. So if you could grow some of the vegetables in your kitchen, your impact would be much lesser for at least some food. Or if you had your own backyard garden, it would be so much lesser compared to many other people. And you know, that's the sort of life that we need to idealize in future. That's the sort of cities we need to build. And I think you must have seen some of these, the news in that how Paris, I think, is trying to build a city where everything you need is at a 15-minute cycling distance for you. And I think the reason to do that is to reduce our ecological footprint as much as possible, and reduce longer commutes, etc. So coming back, to the ecological footprint. So I was talking about a developed country and a developing country. And there are two terms that I think I want you to think about. Okay, we looked at the number of Earths that we would need if everyone looked like you or like us. Naturally, this planet has a biological capacity. It tells us that this is the amount of hectares per person that you can afford. And then this is the ecological footprint, which is the actual hectares per person that we are consuming when we account for all the resources. And you looked at the quiz wasn't very robust, right? It was very simple, and there wasn't a clear answer to things. In some places you might have to point higher answers than you actually put. So again, we need to think of how to make these tools more robust for people to know exactly what their contribution is so that they can then improve or reduce their consumption. But I want you to now go back to the link, and it should, I don't remember where it is, but it should give you an option to look at your country's biological capacity and your country's biological footprint. So if one of you can quickly go there, and look at the biological capacity of Pakistan and the per capita footprint of Pakistan, and tell me whether our ecological credit is there, or are we in a debit, or do we need to improve our lifestyle? So if one of you can do that and put it in the chat box, maybe I can move to Asa. Do you have a question or a comment?
Yes, ma'am, I had a question. So मैं पूछना था कि जिस in a theoretical sense, मतलब आपकी consumption 1 Earth के बराबर हो, that would be perfect, right? Yeah. But is that practically possible? Because even if you do the minorest of things, चलें ठीक है मैं एक electrical car पे switch कर देता हूँ, या मैं cycling कर लेता हूँ, और साथ में solar panels घर पे लगा लेता हूँ, लेकिन फिर भी to some extent मेरी consumption कुछ ना कुछ तो होगी ना, 1.5 towards तक तो जा सकती है. So is it actually practically possible कि हम सारे 1 तक पहुंच जाए, or are we just trying to reduce it and that's the only goal?
So ideally, we should build ethical individuals who bring it down to 1 Earth, right? Only then can the planet survive. Only then can we pass a sustainable planet on to our future generations. But like I said, you and I in Pakistan do not have a choice, but we do have a lot of choices, and we do not make them. And we'll look at how we are responsible for a lot of things not going right in this country, yeah. But there are people who live a zero waste life. There are people who take radical measures to make sure that they need less than 1 Earth. They not only just meet the biological capacity of that they were required to do, they take lesser space than that. And I think the answer to this is a life away from consumption, and a life away from consumerism. This life that you and I live, where even before we wake up, there are 10 products that are thrown at us that we need, buy this, buy that, go for this, go for that. Even I get a lot of ads. I do not go to those links, but I think because of the general Google searches or links that the population around me is going for, I get a lot of clothes and brands continuously being posted at me in ads, because I think they know that's what the general population is aiming for or is looking for, and I automatically get those. And I think that's something that we need to be aware of, that people and the capitalist society doesn't need to tell us what we need. We know what we need, right? We know the number of yes, anti-cap. So we know the number of things that we need. We know we need to keep our wardrobe simple. We know we need to keep our consumption pattern simple. So I think minimalism for me is the way. And as long as you live a minimal life, I think it is possible. And it's not. Maybe you can do an analysis of what will bring your consumption to or your ecological footprint to 1 Earth. What are the radical changes that you need to make? So maybe you go back and give that quiz with changing certain things in the quiz, and then see exactly what you would need to live on only 1 planet Earth. But last time I told you that we need to understand the causes, we need to understand the problems in order for us to be able to solve those problems. And if you look at it, and that's why I think, again, I would come back to the ethos or the crux or the learning or course objectives of environmental sciences is that a lot of these problems that you see on the screen are not completely scientific problems. They have a lot of scientific solutions, but a lot of this is also societal and a lot of this is also mindset, right? If overpopulation is the cause of a lot of environmental problems, that's what we need to deal with as well. If unsustainable use of resource is the cause of the problem, then we need to go back and change behaviors and change the way we have designed our societies today. If poverty, inequity, and injustice is the cause of environmental problems, then we go back and address it, right? And you can see that not all problems, not all causes are scientific in nature. GHA is global hectare, Hania, and I know someone posted what the ecological footprint of Pakistan is. So it's the biocapacity is 0.3 global hectares. Like in the globe, that's the amount of hectares one person can afford. And despite like living a relatively minimal life, we still our ecological footprint still is 0.8 global hectares, which means that we are consuming 0.5 hectares more than we are supposed to, or taking the space more than we are supposed to. But if you compare it, for example, with the developed countries, it will still be much higher for them too. All right, so we looked at that. And then the environmental cost of it. And we will keep coming back to this, and I'll just trigger the question because I do not have a right answer for this as someone who isn't qualified enough to make a statement on this. I do think that when we buy a chair, or when I buy, or when Lams bought this, we have to bring Lams in here. So when Lams bought this wooden table, did it pay? Like, what did it pay? What was the price that it paid? And did the price included the environmental price? What if our receipt said the clothes that you're buying, the shirt that you're buying is costs you 2,000 or 2,500 or 5,000 Pakistani rupees, out of which 3,000 is the environmental cost. That is the amount of energy that was consumed, the amount of colors that were added, the carbon footprint of the industry. If that's the information that you were given with each product, and you had to pay a price for it. So for example, your 2,000 rupees shirt now costs you 5,000 because we say, this is the environmental cost of the shirt and that's why you should pay 3,000 more. Just look at how the behavior of people will change. And I think we need to do that in order to reduce the amount of environmental problems that we have, and we have little time. So what do you think is the approach for us to reduce these problems, or go towards the solution of these? Yes, Fatma, you can go next, and I'll quickly jump to the next lecture because I want to talk about that as well.
मैम सबसे पहले तो हम अपने ट्रांसपोर्टेशन में चेंजेस ला सकते हैं. सबसे इजी तो यही है सबके लिए, लाइक जितना हो सके हम पब्लिक ट्रांसपोर्ट यूज करें और प्लास्टिक बैग्स वगैरह कम यूज करें, लाइक दिस.
Anybody else? Let me also look at the lesser use of fossil fuels. Absolutely. Who else is Afaq? You can go next.
Yes, ma'am. And on an individual level, we can do everything like that. But I think we should be imposing more laws on the big corporations that are, significantly using the environment and destroying it. So I think instead of looking at the personal level, we should first look at them, impose laws to control their activities. And if we are controlling their activity, we are controlling the consumership that they are selling. So as a side product, we can go for a more natural environment.
Absolutely. And the reason why I put that question was that, we can, as a scientist, as social scientists, we can come up with 1,000 solutions. But if the source is not taken care of, we'll continue to do that our entire lives. So for me, I think the approach to solving an environmental problem is to going back to the source and controlling the source, or controlling pollution at the source, rather than saying we'll build something at the end of the pipe, and everyone on the way will be impacted. We go back to where it starts, right? Whether that's behavior, or whether that's industry, or whether that's wastewater that's coming from houses, we come back to each household and tell them how we can reduce wastewater there. How can we reduce water consumption, plastic consumption at those points, instead of thinking about reducing plastic in the end, or taking care of plastic at the end of the way. Yes, absolutely. So thank you for all of that. Let's quickly go to this slide, which I've added this lecture, which is it's very, very teeny tiny. But I thought that if we want to build into the different spheres of the Earth, it's important for us to know the Earth, right? And how many of you, and this is like a fun question, how many of you watched the Big Bang? Just raise your hand, and then my question will follow up. So how many of you watched the Big Bang? 3, 2, 1. Nobody? Huh? Okay, some people watched the Big Bang. So if you've heard, like if you've paid enough attention to the title song, you already must know a little bit about the Big Bang. And I can start it. I can start the timeline for you. So yeah, the Big Bang theory. Yeah. So it starts with our whole universe was in a hot, dense state. And no one's typing. Okay, I can continue. And nearly 14 billion years ago, expansion started with. So we already know from that song that whatever it was, it started 14 billion years ago. So we were in a hot and very, very, very dense state. And 14 billion years ago, a bang happened, and that bang has allowed for a lot of evolution that this planet has faced. So, and this, it was very difficult for me to put this lecture into such a condensed state as well. So I had to reverse and make sure that you get some information at different levels. But I think for us, it would be important to know how life eventually formed. Okay, so all of this was super dense. A Big Bang happened, and then it allowed for evolution to happen. So we started with simple atoms, just hydrogen and helium, and fast forward today, you can see all the life forms, which is us on the planet, right? But after that, I think I just quickly want to go to this, and maybe I can play a video. I was initially planning to explain the whole, so we've left the Big Bang behind. We're now talking about the formation of solar system, and particularly sun and earth, because those are the two components of sustainability that we really want to focus on. But I'll be showing you a video instead of me explaining what it is. And I hope that you can read that timeline when I upload these slides on LMS today. Okay, so quickly, I'll share the video.
Eventually, the gas warmed from the increasing pressure. As the mass further increased, the gravity also increased. And as a result, the temperature continued to rise. A ball of hot gas formed in the center of the accretion disk, creating a protostar, also known as the sun. Finally, when enough gas gathered in the center of the protostar, the pressure generated enough heat to fuse the atoms, forming a star. Outside the star, matter was forming into clumps of gas, dust, and rock, which created protoplanets. These protoplanets continued to grow as they trapped material in their gravitational fields. Because the protoplanets all formed from the same cloud of gas and dust, they travel around the sun in the same direction and in the same plane. The nebular hypothesis also explains how the planets are arranged. The heat and solar winds caused by the sun swept the lighter gases farther out into the developing solar system. This is why the rocky terrestrial planets, Mercury, Venus, Earth, and Mars, are located closer to the sun. The gas giants, Jupiter, Saturn, Uranus, and Neptune, formed in the cooler outer region of the solar system. The solar system continued to evolve even after its initial formation. Large asteroids slammed into planets, and the planets themselves differentiated into layers as they slowly cooled. Although the nebular hypothesis cannot be directly tested, it is a useful description for how a solar system forms. It explains why planets and the star they orbit usually spin in the same direction and lie in the same plane.
Okay, I know someone has a question, so please feel free to pose that question. And in the meantime, I'll come back to the slides. Who had a question? Nobody did? Okay. So the reason why I wanted you to have a glimpse of Geology 101 is because it said how the planets cooled, how they formed their own layers. It basically started with a galaxy, or let's say a cloud, and then that cloud eventually turned into a disk, and then gravity allowed for particles to come to the center. In the center, we had this sun forming, and then at the sides, all of those dust particles were coming together, merging, and then forming the planets. And then that disk just continued to evolve further. And then in terms of formation of gases, there was initially only hydrogen and helium, and then they fused together and heavier elements were formed. And then the planets cooled down or haven't, depending on where they are. And then the most suitable conditions were present on Earth. You don't need to know this in great detail, but it would be nice for you to at least know the whole cycle or the whole timeline of how planet came to this shape. But I think I also wanted to talk about the basic units. So we'll come back to matter. So we all know everything on the planet is matter. And I hope that this is something that I wanted to talk about since last year, but I haven't really gotten the right formula for putting it into the course. But let's just say everything in the environment is matter. Everything is Maya, as we say it in our Urdu philosophy. That's sub Maya here, and that's true for Earth as well. That everything is matter, and then matter actually it goes down to atoms. And I'll not focus a lot on fusion and fission. I'll just tell you that these atoms then combining and forming elements, and those elements then combining together to form compounds, and the compounds creating molecules, they create energies. And those energies allow us to let certain reactions happen in Earth, and also certain life forms to thrive on Earth. And because when you read like the definition of atom in a chemistry related book, it would tell you it's the basic unit of chemistry. No, that's not true. It's also the basic unit of life, because a cell that we get to see also has atoms. Will also, when we talk about biosphere, go even deep down into the DNAs and RNAs and that information. But it's not just the basic unit of chemicals on the planet, it's also the basic unit of life. And then if we look at the origin of the planet, that's the first thing that was formed, right? We started with hydrogen and helium. And consider this a quick revision to your class, and I'll come back to this equation. But consider this a quick revision to your ultimate basic science. So if you look at this, for example, we'll be talking about a lot of these elements. And for example, I just said that hydrogen and helium and were the first ones to be there. We'll be talking a lot about carbon, nitrogen, oxygen, then some of these essential elements like zinc. I wanted you to go back to the periodic table that you were shown in your science classes and understand why all of that was taught to you, because those are the things that life, as well as the chemistry, as well as the physics of this planet is based on. And that's why you had to go through all of that. So this is just like for a quick, so yeah, all the organic chemistry and the inorganic chemistry is based on these elements coming together and giving you all of those essential nutrients. But not all of them are good, right? We will also talk about, so we'll talk about zinc and iron being important to our well-being, carbon and a balance in these cycles and being important for the planet, but some of them are very difficult. So arsenic, cadmium, chromium, their concentrations in water means entirely different thing for us. So again, knowing where they are and why we should care about it is also important. So again, just for you to have a look at, and we'll talk about systems maybe in the next class. I can just now talk about how, when the solar system was formed, eventually we had the atmosphere, the geosphere, the hydrosphere, and lithosphere form. And those are the 4 spheres of environment that we will be focusing on in this class. And that's why I wanted to set the stage here for those 4, that those are the spheres where all of the interaction is taking place, right? So in the formation, then again, if we go into details, we'll know how, oxygen started to build in the atmosphere, how water started to form in the Earth's lithosphere or atmosphere, and how there's a continuous interaction between these spheres and then within the sphere, because if you look at some of the cycles, they are sedimentary, so they only take place in the soil. So soil to water to life to back to soil, and there's no atmosphere involved in it, and we'll talk about that later. So when we said we are going to be looking at environment, we now kind of focus down to these 4 spheres of the environment, which is the atmosphere, the biosphere, the lithosphere, which is the soil or the geosphere, and the hydrosphere, which is the water space. And then we'll look at the different interactions that take place there and how they get complicated, and more complicated for us to eventually resolve. A quick revision again of the very basic science that you had in your school science curricula, that the Earth has 3 sections. And those sections are like the core, the mantle, and the crust. And the crust is basically the lithosphere, the crust and the upper mantle. And that's where all life thrives. And that's where all the interactions between all the other spheres take place. But the core and the mantle also have an important role to play in the Earth that we see today. Was the Earth that we see today always like this? No. So we talk about our tectonic plates, right? And which one of you, depending on time, maybe I can take one comment. If anyone wants to write in the chat box, why do you think these continental plates that we see today are important? Because just like the solar system has evolved, these plates have evolved as well. And essentially what has happened is the mantle has come up, or the more lava form has come up, cooled down, and then formed this surface that we see today. And some of it is still happening, right? So a lot of gases have also released from the lava, and that has taken a part in formation of the gases that is outside or in the atmosphere of the Earth. So when they escaped, or when they came to the top, and when they cooled down, they released certain gases. Plate boundaries are important because they are often associated with earthquakes and volcanoes. Absolutely. So the Earth did not always look like the way it looks to us today. And I find environmental geology really, really fascinating, even though we will not be going there right now or in this class. But I just still want you to have a look at what did the planet look like, and planet Earth look like when it started forming, and what were so if there was like these plates, the way they've been stitched together is because of the movements of that mantle that we looked at, these plates moved away from one another, and the Earth that we see today is what we see today because of that mantle movement, and that then drives a lot of, and you've rightly said, volcanic eruptions. So every time, I think in this lecture, the major takeaway is the formation of soil and then the certain gases that are formed in the air, and the formation of mountains. So for me, the best learning outcome of an environmental geology course is just to understand that when these plates that are together, when they move away from each other, more lava comes on the surface and more land is formed, right? Because that lava comes on top, then it cools down, and then some of the gases escape it, some of the ashes escape it, but eventually it forms more land. And when those, and someone's written it in the chat box as well, when those tectonic plates collide, and we see volcanoes, we see a lot of those natural disasters, when they collide, then mountains are formed. And I think it's such a beautiful concept. I just absolutely love it. So how the movement of these tectonic plates and more lava coming out also does contribute to the concentration of gases in the atmosphere. And when we go back or go to the geological, biogeochemical cycles, we'll look at the natural sources of certain pollutants, right? Because they're there naturally. And then we will also then look at the anthropogenic sources or the human sources of those pollutants or those gases that are not good for the planet. So like I said, this is just for you to understand the Earth that we see today. And also because a lot of times climate deniers would go back and say that's how Earth was built naturally. We actually need to understand that yes, naturally there are a lot of natural sources of things, but then we have exacerbated that by a huge scale. And also that our activities have changed a lot. So because the climate has changed, the impact of these disasters have changed. So oftentimes even the natural disasters, their impact increases because of how we are treating the planet. Okay, so we talked about the Earth. I think we can just stop there. I'll just quickly tell you, if you're wondering, why the virus that we see today, the infamous, the virus that must not be named. Anyways, COVID-19, we're all suffering, and a lot of you do not like the online class as much as I do not like the online class. But if you look at it, the virus's presence was confirmed by the fossil records 3 billion years ago. So I talked about the formation of the planet. I talked about the formation of the solar system. Let's also quickly just look at the formation of life, right? So there's evidence of life 3.5 billion years ago. And then there is evidence of virus presence 3 billion years ago. And then this leads to a lot of more questions, and I hope whoever is more interested in physics, biology, or chemistry looks into these details and tries to learn more. Yes, they live between the living and non-living Bahram. So they can survive in a non-living environment as well. And as soon as they find a living creature, they sort of replicate into gazillion units to drive us more sick. So the cyanobacteria are the bacteria that can produce their own food. They're photosynthetic bacteria, and they release oxygen. Before that, there were bacteria that used to belch methane, that used to release methane. So when oxygen increased because of the presence of cyanobacteria, then the methane was reduced, the anoxic conditions were reduced, and therefore we had more oxygen building up in the atmosphere. And you know how we say there's life on Earth because there's oxygen on Earth. So there's a lot of fossil evidence and explanation to that. But one term that I think I also wanted to think of is that all of those single-celled microorganisms whose records you see 3.5 billion years ago, and then you see records of cells that are organisms that have more defined cells or bigger organelles. And they are called eukaryotic. So this very older ones with single cell, their shapes forming up, all of that is prokaryotic, and this is eukaryotic. And quickly, I don't have a lot of time. Oh, actually, I'm already over time, so I'll just finish here. I think what I wanted to say is, if you look at all of the impacts that this planet has, it is caused by human beings, right? A lot of it is us. So all of this natural extinction that took place in the evolution of the Earth, now us being the more powerful species, we are changing so much on this planet, which is why everyone needs to be made aware of our negative contribution to the planet. And if you look at the timeline, we went back to the timeline billions of years ago when the Earth started forming, and billions of years ago when the life started forming, so around 4.5 billion years ago. And then look at us. So I've cropped the human because I didn't care much. So if you look at us, we're so new on this planet, right? And yet we are such a powerful species that we have the ability to destroy absolutely everything. And we are already witnessing the impact of things that we have done. So I think an important thing for us to know is that we are very, very new, and we hold so much power today in running a lot of things, but then things have gotten out of hand, and that's why we need to focus more on all the sciences, all the social sciences, all the ethical issues to again come together and solve the environmental crisis and the climate crisis that this planet is facing. And because it's already time, I'll probably just stop there. There was just a reflection on the day, and that's what I wanted to talk about, of us being such a new species on the planet and of the power that we hold and how we can change our impact from negative and destroyers of the planet to rebuilders of the planet. Yes, I can share the recording. And by the way, like I said, this particular slide, and I really hope you can go back and listen to it again if it wasn't easy, even though I've put the most simpler concepts on the slide. I've created a very simple note for this lecture as well. I hope you'll go through it and read it, but I'll put these recordings on YouTube because I was encouraged by the school to do that last year, so I'm doing it this year already. So I'll send you the link for this lecture, last lecture on YouTube, and I hope you're all okay with that. And then I'll also upload the link, the slides on the LMS today, hopefully. And I could not welcome the two TAs. It's a surprise. There are two TAs in the class who are hiding behind the screen, but I'll introduce them to you in the next class. And yeah, thank you very much for coming and have a good day. If anyone of you wants to stay back, has a question, please feel free to do so. The rest of you are free to go.
Capacity of 0.5, but in 1960s, the ecological footprint was also 0.5. But today, when we are in the 2017, the ecological footprint has gone high, but the biocapacity has gone down. So are they two opposite phenomena, or like what's the relation between the two?
Can you share your screen? Because then this is exactly what they explain in your book as well, but I would like to explain it here too. So if you share your screen, because I didn't give the quiz, I didn't go through that clarification today. So if you share that for me, it will be easy. So basically biocapacity naturally is the capacity that the planet has, right? So you have a biocapacity, which is highlighted in green. Is that it? And then you have an ecological footprint, which is in red. So it's telling you automatically, let's say, if this office has a biocapacity of like that, there is a certain, let's call it a hectare, and then let's call it 1 person per hectare. But let's say we have now, I have added a lot of resources and it's consuming more space and more resources, and my impact has increased. So even within this space that I'm living, and let's say I start sharing this office with 4 other people. 3 other people. So let's say in all corners of these office, there are now 3 more people. So the biocapacity technically was to just support me because there was enough clean air. So all of those wastes we talked about, right? So the waste that I could put into this room was only, this room was only designed to absorb that amount of waste. And now there are 3 more people who are adding to let's say the food waste that this room can no longer sustain, or the small bin that this room had can no longer sustain. So the capacity was 1, and then the actual footprint now is 4, right? Which means that for us 4 people, we now need 3 more rooms. Okay, so let's say the biocapacity is 1 room, and the ecological footprint or is 4 rooms, right? So we no longer live in this room. Everyone, SSC has given everyone a separate room, and SSC only had this 1 room to sustainably allow for population to put resources into the planet. So yeah, let me rephrase it again. So SSC only had 1 room, and SSC only needed me to take this space because all my consumptions were, this room is designed for all my consumptions and wastes to be absorbed, and nothing goes out of the system. It's sustainable, right? And then now, because SSC has 3 more faculty members that it needs for environmental sciences, they have built 3 more rooms when they initially didn't have the space. So they have claimed more space than they actually could afford. They could only afford to build 1 room, but they have now built 3 more rooms, brought in 3 more people, and the resources that we consume, the amount of electricity, the amount of water that we consume is higher, and the amount of waste that we produce is higher as well. So automatically, the number of people that could be sustained in this area in the department has increased to a certain number. So from 1 room, we have now gone to 4 rooms, right? So the biocapacity, let's say between the 0.5 and the 0.6, you now have what you could sustain was 0.5, and what the amount that, or the footprint that you have, or the space that you're taking up per person is 0.75. Or actually, let's put it this way, that instead of giving me 0.5 hectares of office, SSC is now giving me 0.75 hectares of office, right? So even in that initial space, instead of giving me what I needed, they are giving me more than what I needed. So my impact is automatically increasing, right? So I should have been allocated 0.5 because that's what they afforded, the planet afforded, but I was given 0.75 global hectares because I don't know, because of the lifestyle that I live and because of the demands that I put for the department. So that's my footprint. And now the credit is high. I'm consuming more resources. I'm living on a bigger space than I was supposed to be. And if you keep going higher, of course, if every individual takes more space than they're supposed to be, or consumes more resources than they're supposed to be consuming, then automatically the space that would be available for the other life would reduce, right? So if I want a 0.75 hectare office, or okay, let's look at towards the end, like let's say it's 0.86, right? So I've been given 0.86 global hectares in 2017, when the hectares that I actually deserve, or the hectares that actually the Pakistan could afford to give me, was 0.35, then automatically my ecological footprint is way more than what it was supposed to be. And then let's go back to the question that Asad asked, like, is it practically possible for us to live on one planet? If every Pakistani lived on 0.35 hectares, Pakistan's ecological footprint would be 1 Earth, right? So that's the difference. Because we are living somewhere above that 0.35 and 0.9, all of us, like of course the averages are 0.9, but let's say we live on a scale between that. Because we live above that biocapacity, our ecological footprint is high. Every Pakistani needs 2 Earths or 3 Earths to survive, to live on the planet. Whereas if we lived on just 0.35 hectares, if our ecological footprint was equal to the biocapacity, then we would only need 1 Earth. Does that make sense?
Yes, thank you.
Okay, super. Anybody else? Maybe the rest. I need to see who's here, because maybe they're just sleeping in their bed and forgotten to log off. Okay, so that's it. Let me then stop